Good morning, good afternoon to all the attendees and the panelists joining me today to attend this very interesting webinar. My name is Simon Roberts. I'm the Business Development Manager here at Solis, and I will be the moderator for the event. So before I introduce the panelists to you, I want to let you know that we'll have a Q&A session at the end of the presentation. However, if at any point you have a remark or a question, please feel free to use the chat option. So the agenda for today will be a short company presentation followed by the reason for this webinar, so an introduction to the SolisFAST product range. And then we'll take a deep dive into two key features of that range, which are the stability and the inhibitor tolerance. Yeah, I think that we are well on time, so let's get going. I'm very glad to introduce you to our first panelist, Salim Essakali, who is our head of global sales and marketing. Good morning, Salim.
Good morning, Simon. Good morning, everyone. I'm very glad to be here, and I am practicing the screen sharing here, so I hope that's working. Simon, can you confirm very quickly?
Looks okay.
Perfect. So, yeah, good morning from my side as well. And as Simon was saying before, my name is Salim Essakali. I lead the sales and marketing team here. And it's my great pleasure to briefly introduce you into Solis Biodyne and then actually hand you over to the subject matter expert. So I won't stand in the way here for too long. Just very briefly thought it's prudent to also give an introduction to our friends and partners on the call that maybe don't know us that well yet. We will be celebrating our 27th anniversary this year. We've had the pleasure to be called Innovator of 2021 and top 1% of Estonian companies. And as you can see here, 70 employees, but strongly growing. A lot of catalog products. I will briefly touch base, obviously not on all of the 70. Over 100 custom products, and as it goes with the great work from all of you experts and your customers in the field as well, or your scientists in the field, a lot of publications, and we are also very focused on patents and quality assurance, of course, as we are double certified here. And one of the other questions, again, it's very high level here, right? One of the other questions that I usually get is, okay, what exactly is it that Solis Biodyne is bringing to the table here? And one way to put it is that it's basically two pillars here. One is, like development, production, and optimization of PCR enzymatics. That's what you see on the left-hand side here. And then on the other side, the other pillar is then either our understanding or, depending on how the partner likes to work, the partner's understanding of the genetic target that needs to be obviously detected or amplified here. And putting these two things together is basically what makes up Solis Biodyne and almost 30 years of experience here in exactly what these two pillars are let's say producing, which is in the end PCR and assay developments and applications in the field. And on that note, the main applications unfortunately still are COVID, but we see more and more also the market moving back to all sorts of pathogens, whether it's viral or microbiological. We also get more and more, or see more and more dynamics into the genetic predispositions field, obviously cancer research, precision medicine, but also forensics, veterinary health, agriculture, environmental testing, epigenetics, and this is just a small list. Obviously, you experts in the field know even much more about it. And yeah, we're all hoping actually that soon we can go away from this COVID focus. Almost last slide from my side. One of the other activities that we have been doing here very recently is reach out to all of you experts out there and just try to figure out, what is it? Is there anything? And if so, what is it that Solis Biodyne brings to the table that may be even different to other partners? And three main points came back here very, very systematically. And I'm going to go through them sort of upside down. because the first point is actually the bridge that I would like to use for the expert content that is going to follow here very soon. So again, upside down, starting at the bottom here, the scalability is one of the systematic feedback that we have been getting, is that it's very much appreciated that we've had some recent very strategic investments into our production. And we have reached like multiple higher magnitudes of scales, which is really allowing us then also to go into much larger demands and also different sort of economies of scale. The other systematic feedback that we have been getting is that our customized consulting and development service is something that seems to be very much appreciated, and I can only give it back. This is very, very dear to our heart, that whenever there isn't any idea regarding specific assay development or specific requirements that one has regarding one application, we have this 30 years of experience, as said before, to guide throughout the process in a holistic manner. And then last but not least, or in this case, it's actually the first point that usually comes back, is the room temperature performance and the stability. Many of you may know that all of the enzymes are designed with a stability tag, and this stability tag allows the enzymes and the solutions to be room temperature stable for at least 1 month, some of them actually even 3 to 6 months. Again, more details to be coming very soon here in the later content. And this just allows different sort of features even in the cold chain and in the operations of some of the kit manufacturers, to even get rid of the cold chain. And this is something that is highly appreciated as well. This was the feedback so far here anyway. Last slide from my side, and really I don't want to get lost into this because I know it's a lot to take in, but it's also not easy to, let's say, summarize our portfolio. This is the current try or the current draft. What you see here sort of on the y-axis is the different enzymes, the polymerases, breaking down then into the different brands or the different solutions, and then UNG, and then you see transcriptases and an RNase inhibitor, Ribogrip, which is very, very potent and a strong solution. And then on the x-axis, you see basically the breakdown into DNA, PCR technologies, everything that is sort of in blue, and everything in orange is the RNA technologies. And then below that, you can get lost in all of the master mixes, which we don't want to do here, because that's actually one of our expertises, that whenever you have any requirement, we would actually pick and choose the right solution to go for. And then what I would like to highlight is a couple of development projects. On the right-hand side, the earlier ones, which is, or we are in an early phase, digital PCR, isothermal, and NGS. And then there is some more advanced, which is extraction-free. You see this more on the left-hand side of the slide. And so to go back to the stability topic from before, again, all of these enzymes are designed with the stability tag, so it should have at least 1 month of room temperature stability. But many have actually 3 to 6 months even, and we continuously keep on pushing the data on that side, and we also continuously pressure testing these solutions when it comes to inhibitor tolerance, and also looking into lyophilizations, potential lyophilization options. And the content of this webinar will be focused on one of the flagship enzymes here, one of the flagship solutions, which is called SolisFAST, as you can see here. And we'll deep dive much further into everything that can be done, and also what sort of tolerance those enzymes can take, and what sort of data we can share with you up to now. So with this, I would love to hand over to the subject matter expert here, and I think that should be Ret, right?
Yes, thank you, Salim. So this slide really illustrates how wide our portfolio is. But today, like you mentioned, we'll be focusing on one of our most powerful polymerases called SolisFAST, and the whole portfolio that is organized around it. And for this, we have Ret Reinhard Okubeni, who is our portfolio manager, who will give you an overview.
Hello, everyone. Thank you, Simon, for the intro, and also Salim for giving this overview of what Solis Biodyne is doing in the market in general. I will give an overview of both SolisFAST and also how it fits into our portfolio. Like you heard already from Salim, we are almost 30 years in the market, and also the stable enzymes that we produce have been in the market almost 30 years. From 1995, officially the company has started, and Solis, our stability tag is actually older than that. And what is this stability tag? So the stability tag is a genetic modification that we do with all our enzymes, not only enzymes, but different kind of proteins. They don't have to be enzymes particularly. So this is a modification that increases stability of protein at increased temperatures, including room temperature, but it also increases long-term stability at -20, which is a routine storage condition for this kind of enzymes and PCR enzymes in general. It does not affect enzyme activity, so it's an added benefit for regular enzymes. And we have included in this stability tag in variety of proteins. Here is one example where we have used this stability tag. All the right-hand blue boxes, they refer to our registered trademarks of different DNA polymerases, reverse transcriptases. Also, we have a UNG enzyme, uracil DNA glucosylase in our portfolio. Quite new member, and also RNase inhibitor like ribogrip that Salim already mentioned. And just to summarize maybe briefly what the stability gives, what's the advantage? So it's basically like an insurance policy. It's extra insurance in case you're absent-minded person, you forgot your enzyme tubes on the tabletop after you finished your reaction. That's actually one of the foundation of this stability tag in general, because our founder who founded this company accidentally discovered these properties of this particular enzyme modification. He forgot one of his enzymes that he was working with. He forgot it on the table and discovered it days later, and tested, and it appeared to be very active still. And this was the beginning of the stability tag in general. Absent-mindedness. So it's very important to sometimes be absent-minded and discover new things. Every day what we see, it helps us and our clients when there are customs delays. So the shipments that we ship might be stuck in customs due to different documentation or whatever reasons. And all our portfolio is 30 days room temperature stable, but that allows also fluctuations of temperatures. And our products arrive safely even with custom delays. Also, we have cases where in our clients' fridges have been switched off due to power outages up to 2 weeks, while our enzymes survived and the other ones didn't. For some clients and for us also, there's an extra convenience. You don't need to set up your reaction on ice because of the enzymes. If the assay requires it, then of course you should do it. And the main advantage also is shipment at room temperature, which allows us to be very flexible in where we ship it. And also our clients can use this advantage when they need to travel between different labs, for example, and they don't need to worry about getting a dry ice box to get this one tube from one lab to another. One of the biggest hurdles that come with this regular shipments with dry ice is this big bulky styrofoam waste. And with this stability, we can actually reduce a lot this styrofoam waste, also for different labs that use this advantage. This is an example how the stable enzymes and stable master mixes are shipped. On the left, you can basically ship it in an envelope, simple cardboard box, instead of this bulky styrofoam boxes. Our portfolio is roughly divided into DNA polymerases, also different master mixes for endpoint and qPCR, dye-based, probe-based. We have hot start master mixes, regular master mixes, and the biggest, newest and biggest part of the portfolio is right now even reverse transcription and one-step RT-qPCR solutions, especially during the COVID. One-step RT-qPCR solutions are the most important products. And we, additionally to what you see in our public site, there's also a lot of customization that we do. Let's talk about SolisFAST briefly as well. And SolisFAST, what we try to do with SolisFAST, we are trying to help you save a lot of time from anything that PCR can solve. So anything that the reagent allows to do to speed up your reaction. So we have developed faster PCR reagents, and also what can speed up your PCR reaction is also if you're using more robust reagents, which would allow you to either reduce steps in sample processing or skip any extraction at all. So this is our business, and we are trying to help here. This is the full SolisFAST product range. It has products from all three groups: endpoint, dye-based, and probe-based qPCR. And what does SolisFAST stand for? It is a fast and room temperature stable DNA polymerase. It is based on oligo-based hot start, and the activation of this hot start is very quick, mostly limited to the even the sample material DNA denaturation times needed. It is 3-4 times faster than regular TAC. It is tolerant to common inhibitors, more tolerant than regular TAC. And it has also additional benefit of very high efficient incorporation of DUTP nucleotides, which regular TAC is a bit more picky for. So that allows us to combine this enzyme very well in master mixes with the UNG enzyme. And that allows to avoid or reduce carryover contamination. We have incorporated this SolisFAST in ready-to-use master mixes, 5 times concentrated, and there are different versions. The enzyme itself is inherently more tolerant to inhibitors, and we have several feedback from market where in different kind of applications our clients have seen higher tolerance to difficult sample types. Here is an example of SolisFAST endpoint master mix where it was compared with our regular TAC-based, hot fireball TAC-based master mix, and with difficult soil samples where SolisFAST master mix was significantly better. Endpoint PCR range key features. Your PCR runtime can be from 15 minutes. The master mix is developed for multiplexing up to 18 targets. There is an optional UNG included in different master mix, and also the ready to load master mix is something that you can use to reduce pipetting steps, and you can just you don't need to have a separate loading die for loading to gel, so it's very quick and convenient solution. On the right hand, you see that with even with highly multiplexed reaction, 18-plex reaction, you can run your reaction in 40 minutes. That is like roughly 3 times faster than with a regular multiplex assay with the regular hot fireball TAC polymerase. Here is shown also that the mix works equally well in singleplex and multiplex. And also important is that the UNG that's included in this mix with UNG, it's very effectively inactivated during the PCR, and we have tested it as a post-PCR test with Sanger sequencing. We have seen that there is no residual UNG activity in the PCR product that contains also UNG in the master mix. So SolisFAST Master Mix, some comparison of different runtimes. I will put it back. With similar competitors in the market, show that it's highly comparable or even faster. That some of the fast PCR master mixes are on the market. There is a wide range, wide room to play around with cycling protocol. And basically, the faster you want to go, and also depending on your target and your sample material, room to optimize. Dye-based key features, we have SolisFAST SolisGreen qPCR mix, which roughly we say that from 30 minutes qPCR runtime is what you can achieve. And this is used for singleplex detection from a cyber or FAM channel. And the SolisGreen dye is similar than compared to CyberGreen and Evergreen, but even brighter and more sensitive. And also for those who think of commercializing any of their diagnostic solutions, then in dye-based qPCR, then SolisGreen dye allows you to do it without any extra licensing if you're using a SolisFAST SolisGreen mix as a base component. And there is also some comparison of the master mix used on different cyclers, same cycling protocol. So you can see that the standard qPCR reaction can reach to more than 1.5 hours. Then with the SolisFAST SolisGreen, you can get your reaction done in 30-40 minutes, depending on cycler. And also some examples on the market, fast qPCR dye-based mixes. Here are some runtimes, cycling steps, not runtimes, compared to competitors. Again, similar or faster cycling steps are possible. Probe-based key feature pretty much the same for dye-based in terms of time, runtimes that is achieved. And here, maybe most important, especially if you're trying to develop assays with many targets. So this mix is designed for up to 5 plex assays. And also optional, there is a mix with UNG and UTPs. With all our qPCR mixes, we also have the reference dye option. With SolisGreen mix previously mentioned, there is a ROX option. With the probe-based mix, we have also an option for those who might want to use the Mustang Purple reference channel for signal normalization on cycler where it's possible. And for that, we have a purple mix available as well. Again, similar comparison, at least 2 times faster runtime, which depends highly on the cycler properties. And some similar products on the market that we can easily compare this mix against, and even show, in some cases, even faster performance, and also multiplexing. What is important to note is that fast is a very relative term, and it really depends on a cycler. There are different kind of cyclic programs that you can use, but when we refer to standard cycling, then roughly, depending on the cycler and cycling protocol you choose, it can be roughly up to 1.5 hour, cycling protocol. With fast cycling, when we are reducing the cycling steps, we can achieve, depending again on the cycler, run times from 30 to 60 minutes. And some very special instruments also allow to reduce cycling steps as low as you can see in the referred ultra-fast cycling. And there are not so many instruments on the market, but at least the master mixes allow to use this ultra-fast cycling as well. Here are some common cyclers where all these products have been tested, the qPCR products, and they work very effectively on these cyclers. So altogether, summary of the SolisFAST product range is found here. All of them are stable at 25 degrees room temperature at least 1 month. And Hanna will soon show you more about the qPCR dye-based and probe-based products and share some more interesting facts that has recently been revealed about the qPCR product range. And here I will hand it over to Hanna, who will actually open up why we have used this bold statement for today's webinar, the most tolerant qPCR range in the market. Thank you.
Thank you very much, Reet. Yes, just like you said, now we'll pass on the presentation to Hanna Sein, who is product manager in Solis Biodyne and in charge of the SolisFAST range. Reet already mentioned in her presentation one of the key features of the SolisFAST range, which is obviously the speed and how much time we can save. But there are two really key features that are worth deep diving in, and these are the exceptional stability and a remarkable inhibitor tolerance that we can see in that enzyme. And so please tell us about it, Hanna.
Thank you, Simon. Thanks for the introduction, and thanks to everyone who has joined the webinar today. Happy to introduce to you the SolisFASTqPCR range and why we have called it the most tolerant qPCR range in the market. And I'm going to talk about two different aspects. One of them is high tolerance to higher temperatures, and the second topic is tolerance to common PCR inhibitors. And firstly, I will introduce the topic of stability. What we have seen from stability stress test we are using the SolisFASTqPCR range is that it has exceptional stability features, which allows us to use our classical shipping method, which is without any dry ice and at ambient temperature, which then allows us to reduce our carbon footprint and get rid of using all of these huge styrofoam boxes. And in more detail, we have found out that the entire SolisFASTqPCR range is stable for up to 2 weeks at +37 degrees, up to 3 to 6 months at +25 degrees, 1 year at +4 and 2 years at -20 degrees. And the most relevant temperatures listed here are the ones in the beginning, +37 and +25 degrees. And the stability at these temperatures is what makes this product range one of a kind in the market. It's really unique. And to back it up with some data, I would like to show you some amplification graphs. And these graphs come from our stability tests that we have run with the product SolisFAST Probe qPCR mix with UNG. And what is interesting about these results is that we are not only evaluating the stability of the SolisFAST DNA polymerase, we are also evaluating the stability of the UNG enzyme, which is already incorporated into the mix along with DUTP nucleotides to allow cross-contamination elimination. And what we have done here is that we incubated the test sample of this product at 37 degrees for 2 weeks. And we also kept a reference sample in the tests, which we only incubated at -20 degrees for a short term only. And what we expected to see was no changes in product performance when comparing the reference samples to the test sample. And what we saw was that the mix, even after incubation at +37 degrees for 2 weeks, was still fully able to amplify 5 different targets within one reaction. These targets have all different characteristics as well. And what we also did, we spiked the reactions with DU-containing amplicons, and we saw that the UNG enzyme remained fully active, and it removed all the DU-containing amplicons, which then mimicked the cross-contamination. And we cannot see this these amplification artifacts from the amplification plot here, and all the amplification only happened from the actual template. The efficiency of the reaction remained between 90 to 110%, and we did not detect any significant changes in fluorescence levels and CT values. And the amplification was also specific, meaning that we detected no amplification signals from no template controls and also no precipitation. We achieved similar results after incubating this product at 25 degrees for 3 months, and the same criteria were met. When evaluating dye-based qPCR mixes, an extremely important aspect to keep in mind is the melt curve plots. And this is why I'm also showing you the melt curve plots here with the results we obtained with the product SolisFAST SolisGreen qPCR mix. And we allowed no changes in the melt curve profile after incubating the product at the stress conditions. And here you can see that after incubating the mix at +37 degrees for 2 weeks, no changes in amplification and also melt curve profile were detected. And we also obtained the similar results after incubating the mix at +25 degrees for 3 months. The second topic that I'm going to talk about is inhibitor tolerance. And this is an extremely important topic, and mainly due to 2 aspects. One of them is that when working with different complex sample types, it's even when using classical DNA purification methods, it's sometimes hard to get rid of different inhibitory substances. And secondly, what we have heard also from our partners who highly value reducing cost and time by using simplified extraction methods. And in this case, it's almost inevitable to get rid of the inhibitors, which is the place where inhibitor tolerant PCR mixes come in really handy. And we were actually interested to and positively surprised to hear during the launch of our SolisFAST range that many of our good partners who had tested this product range on difficult samples using either just like difficult samples that were purified but still contained some sort of inhibitors, or also who used simplified extraction methods and were working on crude samples, that the performance was really good. And to understand it better, we decided to put our SolisFAST probe qPCR mixes to a test to see whether we ourselves are also able to detect such a strong inhibitor tolerance. And we are glad to say that the test was successful, and our SolisFAST probe qPCR mixes show good tolerance against common PCR inhibitors, some of which are listed here. And this allows robust amplification from complex samples where PCR inhibition might be an issue. And to explain it in even more detail, what we did, we created a test system, and we wanted to see what kind of an effect do individual inhibitors have on the PCR reaction. And the inhibitors that we tested are listed in this table here, and they come from different sources, and these sample types are the samples that our good partners often use. So to get the fair evaluation, we also wanted to get a comparison point with different competitor products on the market. And from our side, we picked our SolisFAST Probe qPCR mix and the same version with UNG. And the test itself, it's fair to say that we pushed the limits. We did not make this test easy for ourselves by picking tough competition. And the products that we chose from competitor side are, or could be called gold standard inhibitor tolerant competitor products. These are really popular names on the scene of inhibitor tolerant PCR mixes. And the second layer of complexity that we brought into this testing system is the speed. As you can see from the bottom of this table, we used a faster cycling protocol with our mixes, since speed is something that we highly value and we know our partners do as well. And we wanted to see whether our speed feature whether using faster cycling protocols still gives us results that are competitive against the competitor products. And we picked the competitor protocol based on their technical documentation. And as you can see from this table, we were pretty satisfied with the results. We were able to detect that we are well comparable to the gold standard competitors. And in some cases, we are also better. So this test that we ran, this panel, it enabled us to understand the good feedback that we had already received from our clients. And it also now encourages us to also promote this feature of this product range and call it an inhibitor tolerant product range. So I hope that perhaps you now feel a bit more inspired to also bring your PCR experiments to a new level. And we have good news that we can support you here. And we have a campaign in March. And if you order via eShop, then you get a 20% discount on our SolisFAST reagents. And of course, we also offer free samples, and we would be extremely interested to hear what kind of results do you get when you use these samples on your test systems. And to encourage you even more, then for the webinar participants, we have the code FASTWebinar20, which will be also active till the end of April. So please go ahead and order the free samples and let us know how do they work in your system. And just to conclude, I hope now you have some sort of understanding why we call this qPCR range the most tolerant one in the market. And I'm now happy to hand over to Simon for the Q&A session.
Thank you very much, Hanna. Yeah, so now is the time to ask any question you have. I also want to inform everyone that there was a lot of data shared, and the good news is that after the webinar, we will share the presentation and the recording, so you will be able to review and deep dive yourself into all the slides that were presented. I will maybe start by answering one question that has already been asked about high fidelity, and really the focus of SolisFAST is speed and tolerance. So there is no special or superior high fidelity in that enzyme. A question that just came up about isothermal, and Reet, I see you would like to answer it live, so go ahead.
Just a comment. sorry, just a comment that yes, all the developments that we do here, including any other new enzymes, we always plan ahead already having stability tag. So isothermal including also stability tag.
Maybe Reet, since you are active, I have a question. So we focused on qPCR and endpoint PCR for the SolisFAST range. And how about one step? How about our clients who are working with RNA targets?
Yes, we have. Yeah, actually, what you see in the public site of Solis, you really don't see fast one steps, but we have already for 2 years we have had several custom products that we have developed based on the SolisFAST enzyme for our partners who are working in diagnostic field, and one of the partners have also commercialized it together with Solis name. So maybe we can share one example. Hanna, you can push 2 slides ahead. There is an example. Which we can share where our partner in Slovakia, diagnostic kit maker Multiplex TX, has very effectively used one of our fast one-step custom products in COVID testing in their rapid qPCR kit.
Thank you very much. Are there any questions? I see that Han has a question about beta testing. So talking about isothermal, I suggest we take on this topic after the webinar. But short answer is yes, we can make it happen. Any more questions coming from the audience? Maybe I have a little bit of an unconventional question. So we mentioned that there is really a big potential when it comes to short and quick protocols with the SolisFAST range. But how about clients who would be required to use a slower protocol, maybe because it's validated and established, and or it fits a wider range of assays? Is it possible to run slow or slower protocols with the SolisFAST range?
Yes, if for some reason there is a need. Otherwise, I would say that for, let's say, standard slow protocols, we don't recommend SolisFAST because the enzyme is really designed to be fast enzyme. And we have seen that when you would use like very regular TAC polymerase cycling protocols, then it is not performing that well. So there are some limits, and we have mapped out the limits. Maybe Hanna, you can put on the next slide where I have some more information about the SolisFAST, where we don't recommend to go higher with certain cycling steps. So the one that you see in the table is, let's say, our routine fast protocol that is compatible with most cyclers. But if you would need to increase any of these steps, please bear in mind that you don't exceed enzyme activation more than 3 minutes. You don't exceed denaturation step for more than 15 seconds, and you also keep the annealing and extension step 30 seconds or lower. So from if you stay in these ranges, then the product in terms of qPCR product, it works fine. Slower than that, we recommend hot fireball based products, which are also our long historic part of our portfolio, basically.
Thank you. Another question we have is what's the difference between firepole and hot firepole? And this one I think I can take myself. So basically between those two enzymes, it's a hot start mechanism. So one is a standard Taq polymerase, the other one is a hot start Taq polymerase. Now, if maybe we misunderstood the question, and the question was, what's the difference between hot firepole and SolisFAST, then the answer is that there are completely different enzymes, the generation of enzymes really. And in the SolisFAST, we have a different, much faster hot start mechanism, and we have the properties that we already covered in terms of stability, speed, and inhibitor tolerance. Then another question, did we evaluate the percentage of chimeric fragments that are generated with the hot firepole? And here again, I suppose the person asking means SolisFAST. Do we have some answer we can share right now?
Maybe we would need to specify a little bit the question, but or do we have Hanna or anybody who wants to answer?
Yeah, maybe we can take this question after the webinar and discuss in more detail.
Yeah, then this one we'll take separately and we'll answer a little later. The next question is about the kind of sample material that were tested against inhibitors. So what kind of plant material were tested is the question. Maybe here, Hanna, you can specify a little bit how we used synthetic inhibitors in order to have more reliable and comprehensive results.
Yes, indeed. Our in-house testing panel is based on individual inhibitors. In this case, when talking about plant samples, what we tested was pectin and also tannic acids, and the results were promising. But when we talk about real samples that come from like actual plants and not just where we measure the effect of individual inhibitors, then we have received good feedback about different sample types, not only plants, also fungal samples, for example, soil samples, where also like some similar inhibitors may be present as they are in plant samples. We are actually working on an application note where our good partner is also using a simplified extraction method and then combining it with one of our SolisFAST based qPCR mixes. And in there, I hope we can soon share this material with more partners and elaborate on this topic more. But I believe there were like 5 different types of plants tested. Like I don't know, Reetta, can you maybe name some specific ones there?
No, at the moment I have to say I don't have it, but if when we have it ready, then we can definitely share it, and we can also share privately with Mr. Tasselli. All right, next question. Is there a visualization die in some of those mixes?
No, with the pipetting step?
No, not in this range, except for the endpoint PCR, which includes loading die. So it actually functions also as a visual die. So it's a green colored master mix, but separate visual dyes we have not added to qPCR mixes.
Okay, we still have some time, so feel free to add some further questions. Well, it appears we have run out of questions. All right then. Yeah. No more questions. So I believe we'll close the webinar. Any last comments from any of our panelists?
Just feel free to really request for samples for testing, and we really encourage you to also stress test it on different sample types to see how well they perform with any of your maybe more tricky, more inhibitor-rich samples, and share your feedback. This is how we can also add a bit more of your own experience to our product range and share it wider.
Yep, we're always very eager to discuss, engage with our partners. This is how we grow, and this is how we generate new ideas and further developments. So always happy to engage. All right then, thank you very much, everyone, and have a great day ahead.
Thank you, everyone.
Thank you.